Hello students, welcome to my YouTube channel Dear Mathematics and also welcome to the chapter of trigonometry. In this particular video session, we are going to discuss about the trigonometric ratios of compound angles. So first of all, let us define compound angles. The algebraic sum of two or more angles are generally called as compound angles. The angles are known as the constituent angles. If A, B, C are any angles, then A plus B, A minus B, or you can say that A plus B plus C are called as compound angles. These are called as compound angles. If A, B and C are any angles, then A plus B, A minus B, sum of A and B, difference of A and B, sum of A, B and also C are called as the compound angles. And these angles individually are called as constituent angles. Then let us go through the trigonometric ratios of sum and difference of any two angles. And we have to consider the two angles as A and V. So first of all, let us go through the sign of the sum and difference of any two angles A and V. So first of all, let us define the sign of sum of any two angles A and V. Suppose the two angles are A and V, then sign of sum of the two angles A and V. Then it will be sin A into cos B plus cos A into sin B. And the second one is the difference of A and B. That means sine of difference of any two angles. Then sin A minus B is equal to sin A into cos B minus cos A into sin B. Then discussing about the cosine of sum and difference of two angles. Cosine of sum and difference of two angles. The first one will be here cos A plus B, the cosine of sum of the two angles A and B. It will be cos A into cos B minus sin A into sin B. Then the second one, cos A minus B is equal to cos A into cos B plus sin A into sin B. Then moving through the third, and that is the tangent of sum and difference of any two angles. Then moving through the third one, tangent of sum and difference of two angles the first formula is here. The tangent of sum of two angles, it will be tan A plus B, tan A plus tan B whole divided by 1 minus tan A into tan B. The second one will be tan A minus B, it is tan A minus tan B whole divided by 1 plus tan A into tan B. Then the fourth one, cotangent of sum and difference of two angles the first one is here cot A plus B, and that is cot A into cot B minus 1 whole divided by cot B plus cot A, and the last one is here cot A minus B is equal to cot A into cot B plus 1 whole divided by cot B minus cot A. So these are the simple 8 formulas based upon the trigonometric ratios of compound angle. Now let us go through the theorems based upon these formulas. So here it is the first theorem based upon the trigonometric ratios of compound angle, which is given by sin A plus B multiplied with sin minus B is equal to sin square A minus sin square B, and we have to prove this from the left hand side. We have to go to the right hand side. So let us go through the proof of the theorem number 1. So considering the left hand side of the theorem number 1, we have the multiplication of sin A plus B with the sin A minus B. Let us put the value of sin A plus B here. It is sin A into cos B plus cos A into sin B, which will be multiplied to sin A into cos B minus cos A into sin B. You can see that the first terms of both of the parts are equal. That means you can consider A as sin A into cos B, and you can consider both of the second terms as V, as they are equal in both of the parts. That means the second term will be cos A into sin B. By considering sin A into cos B as A and cos A into sin B as V, you can define an identity here which will be equal to A plus B multiplied with A minus B, and you know that this will be equal to A square minus B square. So by applying the algebraic identity here, we can have, then simplifying this step, we can have sin square A into cos square V minus cos square A into sin square V. As we need only sin square A and sin square B, that means all of the terms must be from the sine function. So every cosine function will be converted into the sine function. So it will be equal to sin square A multiplied with 1 minus sin square B, because the value of cos square B is equal to 1 minus sin square B. Similarly, in place of cos square A, we can write down 1 minus sin square A multiplied with sin square B. Then simplifying this step, we can have sin square A minus sin square A multiplied with sin square B minus sin square B plus sin square A into sin square B. So cancelling the sin square A and sin square B with minus sin square A and sin square B, the remaining terms are here sin square A minus sin square B, which is the required right hand side of the given theorem. So the theorem has been proved here. Then moving through the theorem number 2. Theorem number 2 is like this: sin A plus B multiplied with sin minus B is equal to cos square V minus cos square A. So let us go through the proof. To prove the theorem number 1, just we have to consider the concept of the theorem number 1. From theorem number 1, okay, we know that, you can write down, we know that sin A plus B multiplied with sin A minus B is equal to sin square A minus sin square B from theorem number 1. In the right hand side, you can write down from theorem number 1. In place of sin square A, you can write down 1 minus cos square A. In place of sin square B, you can write down 1 minus cos square B. So it will be 1 minus cos square A minus 1 plus cos square B. Cancelling both of the 1 and minus 1, we can have sin a plus b multiplied with sin a minus b. You have to repeat these steps in the left hand side. So sin a plus b multiplied with sin a minus b is equal to cos square b minus cos square a, and here it is the proof of the theorem number 2. Then let us go through the theorem number 3 and as well as theorem number 4. Now let us discuss about the theorem number 3 and theorem number 4. The multiplication of cos a plus b with cos a minus b is equal to cos square a minus sin square v. So here it is the proof of the theorem number 3. Cos a plus b multiplied with cos a minus b. By considering the left hand side, we have cos a into cos b minus sin a into sin b multiplied with cos a into cos b plus sin a into sin b. Again, by applying the same algebraic identity as we have applied in the theorem number 1, here we are getting the whole square of cos a into cos b minus the whole square of sin a into sin b. So it will be cos square a into cos square b minus sin square a into sin square b. But we need cos square a and sin square v in terms of the result. So cos square a multiplied with, we don't need cos square b. So cos square b will be converted into the form of 1 minus sin square b minus sin square will be in the form of 1 minus cos square a multiplied with sin square b. Then multiplying cos square a minus cos square a into sin square b minus sin square b plus cos square a into sin square b. So cancelling cos square a sin square b with minus cos square a sin square b, we are getting the right hand side of the theorem number 3, and here it has been proved. Then considering the theorem number 4, theorem number 4 is very much similar to the theorem number 3. Just we have to prove the multiplication of cos a plus b with cos a minus b is equal to cos square b minus sin square a. So let us go through the proof of theorem number 4. We know that cos a plus b multiplied with cos a minus b is equal to cos square a minus sin square b from theorem number 3. But we need cos square v minus sin square a. So by applying the trigonometric identities here, 1 minus sin square a minus 1 minus cos square v, then simplifying the above step, 1 minus sin square a minus 1 plus cos square v, then it will be cos square v minus sin square a, cancelling both plus 1 and minus 1 here. So this is the required answer. Just write down the steps present in the left hand side. So it is cos a plus b multiplied with cos a minus b, and their multiplication is cos square a minus sin square b as well as cos square b minus sin square a, and here it has been proved. So here it is the proof of the theorem number 3 as well as the theorem number 4. Then moving to the last 3 theorems of this continued session of trigonometric ratios of compound angles. Then let us go through the theorem number 5, and here we have to show that sin A plus B plus C is equal to sin A into cos B into cos C plus cos A into sin B into cos C plus cos A into cos B into sin C minus sin A into sin B into sin C. So let us go through the proof of theorem number 5 by considering the left hand side here sin A plus B plus C. But let us consider the sum of B and C, that means B plus C as D. Let us consider B plus C as D. That means sin A plus, in the bracket B plus C, which will be considered as D, another angle D. So sin A plus D, it will be equal to sin A into cos D plus cos A into sin D. Then by applying again the value of D here, it is sin A multiplied with cos B plus C plus cos A into sin B plus C. Then by putting the value of sin A multiplied with cos B plus C is equal to cos B into cos C minus sin B into sin C plus cos A multiplied with sin B into cos C plus cos B into sin C. Then multiplying the terms here, it will be equal to sin A into cos B into cos C minus sin A into sin B into sin C plus cos A into sin B into cos C plus cos A into cos B into sin C. Then just rearranging these terms here, we are getting sin A into cos B into cos C. Then here it is the second term, cos A into sin B into cos C. Here it is the third term, plus cos A into cos B into sin C. And then the last term is here, containing all the terms in terms of sine function, sin A into sin B into sin C. And here it is the proof of the theorem number 5. Then let us go through the theorem number 6 and 7. So here these are the last 2 theorems based upon the trigonometric ratios of compound angles. Theorem number 7 is taxed for you, and here it is the theorem number 6. I will prove it, and this will be the theorem which is taxed for you, and you have to prove this based upon the concept of theorem number 5 and theorem number 6. So let us go through the theorem number 6, and it has been given that we have to prove that cos A plus B plus C is equal to cos A into cos B into cos C minus cos A into sin B into sin C minus sin A into cos B into sin C minus sin A into sin B into cos C. So let us go through the left hand side cos A plus B plus C by considering the sum of the 2 angles B plus C as another angle D. We are getting it as cos A plus D. Just we have, suppose B plus C is equal to D. Then here we are getting cos A into cos D minus sin A into sin D. Then by putting the values of D here, that means B plus C minus sin A into sin B plus C. Then applying the value of a cos B plus C here, cos B into cos C minus sin B into sin C minus sin A multiplied with sin B into cos C plus cos B into sin C. Then multiplying these terms here, it will be cos A multiplied with cos B multiplied with cos C minus cos A multiplied with sin B into sin C, then minus sin A into sin B into cos C, minus sin A into cos B into sin C. Just rearranging the terms here, just replacing or interchanging the position of the last two terms, we can get the particular right hand side here. Then that will be equal to cos A into cos B into cos C. Here it is the first term. Then here it is the second term, minus cos A into sin B into sin C. This is the second term. Then this will be the third term, minus sin A into cos B into sin C. Then this will be the last term. That means minus sin A into sin B into cos C. And here it is the proof. Here it is the proof of the theorem number 6, and I have already told that theorem number 7 is task for you, and you have to prove this by using the concepts of theorem number 5 and theorem number 6. So today we have discussed about the definition of trigonometric ratios of compound angles. What do you mean by compound angle? What is constituent angle? Then we have discussed about the sine, cosine, tangent, cotangent of sum and difference of any two angles. Then we have gone through some of the theorem, total 7 theorem we have discussed in this particular video session. In the next video session, we are going to discuss about some of the problems based upon the trigonometric ratios of compound angles. Till then, thank you.